right, we'll get back to that mystery mean problem a little later on. Right now I'd like you to do, we're going to do a little thought experiment, and I'm sorry we're going to have to put this way up here in the margins. So a thought experiment. So on a number line, if the population mean was here, and I took a sample, and its value ended up being there, the distance from population mean to x is, let's call it d subscript mu to x bar. That distance, I'm sure you would agree, would be the same distance as going the other way, the distance from x bar to the mean. And so if we said that in 95% of all samples, x bar is within 2 standard deviations of the mean, then we can conclude, therefore, in 95% of all samples, mu is within 2 standard deviations of x bar also. Okay, so from that, if we have x bar and we're looking at a range or an interval of plus or minus a certain value, let's say 2 standard deviations, it sets that up as our interval, mu should be within this interval. And that's the basis for our confidence interval. So a confidence interval for a parameter has, first of all, it has 2 parts. And the first part is an interval of plausible values. And by plausible, I mean reasonable or likely. So plausible values for a parameter so an interval of plausible values for a parameter. And it's written as the point estimate, sometimes it's called estimate, plus or minus margin of error. So margin of error, you probably have an idea of what that means. Is something that tells us how close the estimate tends to be to the parameter. In other words, it's the distance plus or minus from the point estimate, Remember, the point estimate is the value of the statistic that we are going to use to try to estimate the parameter. So the distance plus or minus from the point estimate to used to create our confidence interval. Create our confidence interval. And the second part is a confidence level. And a confidence level we can call C is the expected success rate the expected success rate for intervals calculated using this method. In other words, in C% of all possible samples, the method would yield or in other words give an interval that captures in other words contains the true parameter the true parameter value. Okay. For example, at a 95% confidence interval, the distance between the statistic or the estimate and the parameter will be within the margin of error 95% of the time. Now, we have a few different ways that we can write a confidence interval. So, for instance, if we're talking about the mean, x bar, being 15, and the margin of error being plus or minus 5, it can be written as 15 plus or minus 5, or 10 to 20, because of course if I add and subtract 15, those are the numbers I get. Or I can say it as a range like this. The mean is between 10 and 20. Or I can give it as an interval in brackets. All right, so now we come to activity number 2, exploring confidence intervals. And I'd like you to have a look at the applets at rossmachinechance.com, confsim.html. You are going to set the confidence interval not to 95, but to 90%. And you can, in this applet, you can try proportions or means. So you might want to try both while you're playing around with it. And you're going to have the interval first set to 1, So basically you're just doing one sample, calculating one confidence interval. Pi, which is the same as the mean in this case, or whatever your parameter is, the mean, or it could be the proportion. So the value is going to be 0.5, so that's the probability of the value, and then n equals 50. So we'll have a look at this in a minute. And you can use recalculate and reset. Okay, note that the point that you see will be an estimate. Your point, your point estimate, and the green bar is the interval. So go give that a try, and then you can come back. Oh, one more thing. In number 4, so when it says reset and choose sample 15, you're going to set intervals is going to be 50. Okay. What else did I want you to... Yeah, so give that a try and come back.